Okay, I want to talk to you guys about limiting reagent and percent yield in this section. So if you were a carpenter and you wanted to make you wanted to make tables and you had 2 tabletops with 7 table legs, you'd need 8 legs to make 2 tabletops. So your limiting reagent, the thing that you don't have enough of, is table legs, and you can only make 1 table in this situation. So table legs is your limiting reagent for tables. So that's called the limiting reagent. It's the thing you have in the least amount. The thing that's in excess in this example is the tabletops. You have 2 of them. You have more than you can use with the legs that you have. So that's called the excess reagent. So we're going to use that for this section, limiting in excess. So what don't you have enough of, and what do you have too much of? Okay. So if you have something that's insufficient, that's your limiting reagent, or you might hear it called limiting reactant if you look at different places online. So you'll see it said or written both ways. Limiting is the one that determines how much you can make of a product, so like the tables. Excess is the one you have too much of. So in that example, we had tabletops. We had too many tabletops. So remember, we're always going to have balanced equations when we do stoichiometry. We're going to have 1 nitrogen gas, 3 hydrogen gas particles to 2 ammonia particles that we make. We can look at it as molecules, or we can look at it as moles. So this is the before. Say, for example, we have 2 molecules of this and 3 molecules of this in real life. It's just like when we go to the kitchen, we're going to do our recipe, and sometimes we have too much of something and not enough of another. So in this situation, I have 3. That's good because I need 3. But I have 2 of these. So which one is my excess? It would be the nitrogen. I have too much nitrogen. I have just enough of this. So this is my excess. This is my limiting. Okay. When the reaction happens, if I use this situation right here, I would have 1 of these guys left over, none of those guys left over, and I would make 2 molecules of this. Okay, so this is my excess guy. I have this left over at the end, and this was my limiting. So see if we can use it for example. Say we have this situation. We go in the chemistry stockroom. We have 80 grams of copper, 25 grams of sulfur. How much of this can I make? Which one do I have too much of? Which do I have too little of to make this product right there? Okay, sulfur, copper makes copper sulfide, copper 1 sulfide. So we take what we know and we're trying to figure out our limiting, and we have a balanced equation from there. So it's 2 coppers to 1 sulfur to make 1 product. So that's what we're saying here. And so we're going to take both of the grams we have from the stockroom, and we're going to figure out how much we would need, how many moles we have of each thing. So grams to moles, molar mass, grams, molar mass to moles. And then we know we have a 1:2 ratio. So if I have that many moles of copper, I need 0.63 moles of sulfur. How much do I have of sulfur actually? I have actually this much. So this is going to be my excess, and copper is going to be my limiting. Okay, so that's how we figure that out. Here's a problem you can try on your own. And then we're going to use the limiting reagent to figure out how much product we could actually make. Now we know the limiting, and we're going to use that information. So same situation we're talking about. Now, how many grams of product can I make, knowing who's limiting? So you're going to use my limiting reagent. I figured out who's keeping me from making a lot of product, and we're going to use that to figure out the grams that we're going to form from that many moles. So this is my limiting. So this is the one that's limiting me from how much product I can make. I'm doing the mole ratio from the balanced equation. I'm using molar mass, and it's telling me how many grams I can form. Okay, so that's the maximum amount of product I can make because this is my limiting reagent. So make sure you understand how these work. It's important. Here's another problem for you to try. And then our last section in this little video is about percent yield, and we'll use this in the lab to figure out how well you do in your labs. So frequently in chemistry you're graded on your percent yield. So let me show you how to do the math of it. And I usually have a question or two on this on quizzes and tests. So percent yield is really like a batting average, or how well you did on a test or a quiz. You're doing the same kind of math. Theoretical yield is the maximum we could make if nothing went wrong in the lab and we didn't have any left over in a beaker or on a test tube or on a spatula or something like that. So that's what we could happen with a miracle, like nothing, like not in reality. So theoretical yield is not reality, but what could happen if there was no actual lab that we did, and the actual lab is the one that you'll do in lab, and that's how much you'll get of a product. It's called the actual yield. So all we do for the math is figure out what you got in the lab in grams, divided by what you should have gotten if it was a perfect world, theoretical yield, multiplied by 100. Same thing like when you see how you did it on a test. Say you got 9 out of 12 on a test. You take 9 divided by 12, multiply by 100 to see your percentage, how well you did on a quiz or a test. Same thing, percent yield. So let's try it. So here's my balanced equation when I heat this up, calcium carbonate. And I know that I have this many grams to heat up, and I want to figure out how much I should get when I do this in the lab. So it's a good way to check to see how much you should produce in the lab, to see if your technique is good in lab. So I'm starting with that. I'm changing to moles. Then I'm changing to moles of what I care about, and I'm figuring out the grams. It's a 1-to-1 ratio from the balanced equation. That's the mole ratio. So I start with 24.8 grams of my reactant. I use the molar mass of the reactant. I use the mole ratio 1-to-1, and then I use the molar mass of the product. I should make 13.9 grams calcium oxide in the lab if everything was perfect. And then you'd have to go to the lab, try the lab, and find out your percent yield. Here's another one to try for theoretical yield. And now we're going to use that information that we just figured out from that last problem and see what the percent yield. So we actually produced 13.1 grams in lab, but remember we just figured out the other one was 13.9 grams. So we're going to take these two numbers and figure out the percent yield. So 13.1 grams in the lab. We should, in a perfect world, get 13.9. Divide this, take this, divided by that, times 100, gives you that. So if you might want to try this in your calculator to make sure that you know how to do percent yield and get the correct answer. So that's percent yield. We use it a lot in lab. There's another problem you can try. Here's our quiz. So get ready, paper and pencil, calculator, and let's try it. See if you can do these kind of problems. So we have a reaction, it's balanced, double check that. And we want to know if we had these two things, how much product could we make? So this is like the first problem I showed you. So you might want to go back and check it out if you forgot how to set this up. And pause me when you're ready, and then I'll give you the answer after you unpause me. Alright, here we go. Here's the answer. So you should get that if you did it correctly. Let's try the next one. How many grams of water can be formed from those grams? So you're going to have to write a balanced equation first, and then do the kind of problem we did at the beginning of this lecture segment. So pause me when you're ready, and I'll give you the answer in a sec. Alright, so that should be what you get if you balanced everything correctly and you did the math right. Last one, percent yield. You're going to start with 14.6 grams you make 14.6 grams of carbon dioxide when you burn that many grams of the fuel. And we want to know you need to find the theoretical yield and then do the percent yield when you're done. So pause me and I'll show you the answer. Alright, here's the answer. You should get that, so double check and see if you can do that correctly. And I will talk to you soon. It's a really important section as well, so make sure you're understanding all this math. Alright, I'll talk to you soon. Bye-bye.